Earlier that year, Jacob Winther, Danish by birth but at that time a doctoral student at Yale University, had published an important paper that showed how the microballs and microsausages in fossil bird feathers occurred only in dark-colored areas in the fossil. They were melanosomes, not bacteria. He argued very convincingly that if they were bacteria that had invaded the feather to feed on minerals in the decaying specimen, they should be distributed equally all over the surface, on both dark and pale-colored stripes. We accepted his view and immediately applied this brilliant insight to fossil specimens we had been working on with our colleague Dr. Fucheng Zhang from the Institute of Vertebrate Paleontology and Paleoanthropology in Beijing. Fucheng had been a postdoctoral researcher in Bristol in 2005. He had brought over examples of fossil feathers from dinosaurs and birds, and we had been studying them. The feather chippings came from Sinosauropteryx, a slender 1 meter long, 3-foot dinosaur with a long tail and short arms, not a flyer. But the Sinosauropteryx fossils preserved beautiful examples of whisker-like feathers along the back and as tufts down the tail. Melanosomes, we knew, were the hollows in the keratin protein of a feather into which the pigment melanin is inserted as the feather grows. Ball-shaped melanosomes in our samples showed Sinosauropteryx was ginger. It had a neat ginger and white-striped tail. We had objective evidence for the color and color patterns of a dinosaur. The bounds of knowledge had expanded into an area that a week before had been speculation. Science beats speculation. This is the theme of the story that follows. How science has pushed back speculation in dinosaur science. Not so long ago, the only answers to questions about dinosaurian paleobiology, such as how fast did this dinosaur run, could this dinosaur crack bones in half, what color was it, were little more than guesses, even if informed ones. Now, these are questions that can be tested with evidence. That's science, and the switch from speculation to science is a massive advance. I have had the good fortune to live through this astonishing revolution, starting in about 1970, when the transformation of dinosaurian paleobiology began. One by one, the speculations about evolution, locomotion, feeding, growth, reproduction, physiology, and, finally, color have fallen to the drive of transformation. A new breed of dinosaur paleobiologist replaced the older ones, and they have applied a hard eye to the old speculations. Smart lateral thinking, new fossils, and new methods of computation have stormed the field. Beginnings. Like so many, I became fascinated with dinosaurs when I was young. When I was 7, I was given a classic little book, Fossils, A Guide to Prehistoric Life, by Frank Rhodes, Herbert Zim, and Paul Schaffer. What excited me was that the illustrations were all in color, unusual still in the 1960s, and that there were not only pictures of fossils, but reconstructions too. The text reflected the knowledge of the time. This is what Tyrannosaurus looked like, based on the classic studies by Professor Henry Osborn of the American Museum of Natural History, and this is how the dinosaurs died out, rather slowly and perhaps as a result of long-term cooling climates, or maybe simply because they were too stupid to adapt to a changing world, according to the ideas of Professor Lee Van Valen of the University of Chicago. The assertions were clear, although the only reasons given for why we might wish to accept or reject the explanations was that they were the views of distinguished professors at distinguished addresses, and sometimes with distinguished beards. Nonetheless, as a 7-year-old, that was all I needed. It never entered my head to question the authority of something written in a book, especially since most of the key information in Rhodes, Zim, and Schaffer was widely repeated. In any case, what could Professors Osborn and Van Valen actually have done in order to test what Tyrannosaurus looked like, or how the dinosaurs died out? Dinosaurs are long-dead animals, represented now by skeletons and isolated bones. The extinction of the dinosaurs happened 66 million years ago, so how on earth could a scientist hope to investigate it scientifically? What is science? This was the point being made by Sir Ernest Rutherford, the New Zealand-born physicist who made his name at the University of Cambridge with the discovery of the half-life of radioactive elements, when he stated, around 1920, that all science is either physics or stamp collecting. Many hard-nosed physicists might agree with him even today. Nonetheless, he was ruling that much of chemistry, biology, geology, and the applied sciences